Okay, let's continue the class from the slide number 13, routing protocol concept. And in the last class, we already completed this extended ping command. Ping is the ICMP echo command to check the network, to check the system is connected properly in the network or not, to the network or not. This is called the ping command. It sent out the ICMP packets, then it's echo this packet from the target computer. We have to send out the packet, ICMP packet with the target IP address. Okay, with the target IP address, and the target IP received the ICMP request, then it's replied back. This is the normal ICMP request using this ping command. Normal ping also, I already give you the example of this normal ping command. This is the command prompt. This is the command prompt. Inside this command prompt, you can type ping command, and 8.8.8.8 is the Google DNS. And here we'll get the ICMP reply from the Google DNS server. And this the target IP is 8.8.8.8. This is the DNS server of this Google the Google DNS server. And here is replied back from the Google DNS server, and byte sense and time, round trip time, it's not more than 100. One packet, one ICMP packet is 123 milliseconds in the round trip. Then my connection is not so much slow. Okay, not it's expected. It's working fine. And TTL means time to live, how long it can resist in the router networking, cloud networkings, how much it can resist this ICMP packet in the cloud router network. So it can remains up to the 116 hop count. After this, then it will remove by the routers. Okay, this is the ping command. Then apart from this ping command, it can extend some of the commands here. There are different types of lists are there. Okay, different types of lists are there. So for doing this enhancement of these connections and checking more options in the ICMP. Okay, that's all in this extended ping command. And this default routes defines where packets will be sent if no specific route for the destinations is listed in the routing table. If no default route is set, the routers will discard all packets with destination address not found in routing tables. So default route is what? Default route is a router defines when the packet will be sent if there is no specific route for the destination. If there is no specific route for this, then destination network is listed if the destination network is listed in the routing table or not. Okay, routing table or not. Then if there are informations in the routing tables, then it's forwarded to the next neighbor adjacent router. Then if there is no routing tables, if there is no information in the routing table, then the routers will discard all the packets. Okay, so these are the default routes. Default routes, there is no proper configurations in the routing tables. It's simply connected and it's checked. Then if there is no tables, then sometimes it added up in the routing tables, then it discarded sometimes. Okay, so this is the default connected route. Okay, so we have a network of three routers. Let's see in the last pictorial. Three types of routers here. R1, R2, and R3. R1, R2, and R3. But in this R1, R2, and R3, we have a different network domain. In this R1 to R3, R1 to R3 is the 10.0.0.0.0 slash 24 slash 23 network. And here, 192.168 .0.0 slash 24. Okay, slash 24 network. Here, let's see. We have connected a network of three routers. Router 1 is directly connected to the to subnet 192.168/24 and 10.10 of slash 8. R3 is connected to the internet. Okay, here is the routing tables of R1. R1 having these routing tables. There are some I'm copied out from the internet. Some of this mistake is there in the slash route. Okay. Slash 8 10.8 is a variable subnet. Is a variable subnet. If we take out this routing IP, so IP routes in the in this R1. Let me first let me open my Cisco Packet Tracer. Okay, let me do this in this Cisco Packet Tracer. Here we have routers of this 1, 2, and 3 routers. This is the router 1 and this is router 2 and this is router 3. You can say this is R3 and this is R1 and this is R2. Okay, we have 1, 2, 3 router 1, router 2, and router 3. Then we have to interconnect those router using this straight through cables. We have Ethernet port here. Okay, all these routers are interconnected here. And this domain, this domain is 10.0.0.0.0, and here we have this 192.168.0.0. we have two network domains up to this point. Between router 1 and router 2 and router 1 and router 3, we have these network domains. Let's open this router 3 configurations, and in this config here, this network is connected through this interface. Let me show the interface. Option preferences, so name label, always port labels. Okay, gigabit 0/0 is connected to this router 3 to the interface port of gigabit 0/0, same thing. And from the router 1 to router 2, gigabit 0/1, gigabit interface number of 0/1 connected to this router 2 of the interface port of 0/0 of the gigabit. So we are using this 0/1, the 0/0 and 0/1 from the router 1. Let me check the router 1 first. 0/1, we have to turn on the interface of this. Okay, and the IP address of this 0/0 is 10.0.0.1. I'll give it this one. Okay, and this one IP address, that's all. And 0/1 is the site. I'll turn it on. 192.168.0.0.1. Sorry, there are some invalid number. 192.168.0.0.1. Sorry, .0.1 is the IP address of 0/1 interface of the router 1. Okay, now it's connected here. Let me turn up this connection again. Configurations 0/0 and turn on this IP address of this 192.168.0.2. We already give here 0.1. Here we have to give this 0.2. Okay, so let me turn on this also. In the configuration 0/0 on and 192.16, sorry, 10.0.0.2. One already assigned in this 0/0 of the router 1 interface address, and click OK. Okay, now it's all green. All the connections are all green based on this interface IP address and all. Okay. So to solve the R1 IP routes, how to do this? So IP routes. For doing this, we have to click this one and this goes to the CLI mode and press enter. Inside the CLI mode, and we are in the configuration mode. To this, to go out for this, we have to exit. Okay, and exit again, and going to the router configurations R1 with the hash is the global configurations mode, not in this normal mode. It is in the global configuration mode, and IP I have to type it in here is this one. So IP routes. Okay. So IP routes. So IP route. So in this, we are having the routes of the different types of network connected using these different interfaces here. Let me show the previous network here. Okay. Here R1, we are having this R1, R2 and R3. But right now we are opening the routing table of the router 1. In this router 1, we have the two connected routers. One is router 3 and one is router 2. With the different network domain, we can say that 10.0.0.0 slash 24 sorry slash 8 192.168.0.0, this is a slash 24 network, and the classy network. Okay, let's see here. If we are typing this so IP routes, in the routing command line, below this we have a short abbreviation with the descriptions of the short form. L local, C connected, okay, and S is static, okay. There are different types of connections are there. L local and C connected, only local network. And here, let's see, gateway list. Gateway of last resort is not set. No last resort gateway setup. Here internet, there is no last resort of gateway is not set up here, and also there is no last resort of this gateway is not set up here. 10.0.0 slash h is variable subnet. Okay, there is no fixed subnet here. Two subnet, two marks are there, and C connected to this directly in this, okay, connection direct. And local, the local is this IP address. Okay, this is the connected network, this domain, and connected to this network, to the network using this interface port number. Okay, this router doesn't know about the next routers, what IP is in the next neighboring routers, and what is the interface address. Okay, and 192, this is also variable subnet. Two marks are there. One is 192.168.0. This is the interface network connected to this, and with the interface port and the IP address of this. Okay, in this okay, this is the example of this connected network using this Cisco Packet Tracer, this connected interface. If you type this so IP, then it will come this information based on this second slide. Okay, based on this second slide, it's more or less same with this. Okay, more or less same with this, but there are some mistake in this last network. Okay, anyway, let me move on to this next. The same, let's continue to this. So notice the lack of the default gateway, lack of default gateway or default routes if R1 tries to access the public address. Okay, public address, the packet will be dropped because no route to that IP address has been found in the routing tables. Okay, there is no public net to go out to the external network. Okay, it's already drops in the IP address, no routing table found. Okay, there is no routing tables in this network to go out to the public IP address in the router one, so it's drop the address. Okay, it drops the IP address in the PDU. Okay, to create a default static routes on R1, we need to use the following commands. So to complete the routing informations, routing data, all these things in the router one, we have to do this routings. Okay, IP routes, we have to give this information. So the command above instructs R1s to match all IP address and subnet marks and send the packet to the 10.0.0.2 to the next routers in this. Okay, these IP addresses, interface port IP addresses 10.0.0.2, and here this is 10.0.0.1. Okay, these two IP, this is the interface IP address of this 10.01. Okay, let me move on a little bit here. Okay, right now this router one doesn't know about the 10.0.0.2 IP address of the router 3 interface address of gigabit 0/0, and IP assigned to this port is 10.0.2. Okay, this is assigned IP of this interface of the router 3, and from this router 1 does not know about the interface port of this and the IP address of this router 3. This is the neighboring, okay, the adjacent neighboring routers, but router doesn't know. So to configure this default static route in the router 1, we need to use the following commands. So to know those things, we have to set up these things. The routing table of R1s look like this. First, in this configuration mode, we have to enter this IP route .0.0.0.0 to the subnet marks of this .0.0.0.0.0. This is called the command R1 to match all IP address and subnet marks and send all the packet to this, okay, to the IP. Okay, zeros the 10.0.0.2 in this network area. Okay, and to check for this in the router one, so IP routes. Gateway of last resort is 10.0.0.2 to the network. Here, all these network informations, then starting from this 10.0.0 is routed to this interface, okay, to the network of this. Means it's going out to this network, okay. It's going to out to this network. This 0.0 means 0.0 means R1 to match all IP address and subnet address and send the packet to this network, to the router tree. Okay. Okay, this 10.0.0, this is the subnet mask of these two, and connected is this, and L is this one. Okay, the link is this one in this Ethernet, and here 192.168, this is the subnet mask of this is this, and all these things. And here we have a star mark of this. All these networks sent via of this 10.0.0.2. Okay, to do so, we have to enter this enter to the router one, and we have to configure it, the router one. Here we are not in the global configuration mode. We have to type enable. We are in a global configuration mode. Configure terminal. Configure terminal. Okay, we are in the configuration terminal mode. To configure the terminals, here we are in R1 routers. We did not change the host name here. It's still this router in the config, and here we have to do this command. Hash means this global configuration mode. Okay, IP routes, we have to type this 0.0.0.0 IP, any subnet marks 0.0, any subnet marks route to this IP. That's all. Okay, it's configured the IP address, and we have to go out from the global configuration mode from this configure terminal by typing exit, and so IP route, and here we'll get this routes, okay, via through this, using this S. Okay, this is called the static route or the default route. Yeah. Okay, these are the things in this, okay, default static route. So let's see here. Notice how the gateway of the last results is now set to this 10.0.0.2. There is also a route marked as S star in a routing table, which means that the static default routes we have just configured in the candidate default route. Since routers can learn about multiple default routes, and star indicates that this is static routes, is a candidate to become a default route. So like this we can ping the ping it now. So let's see here. See, let's try to ping this IP address from the router one. Ping 4.2.2.2. Okay, it sent out the ICM packet from the default routes, and then the success rate is not 100%. 4.2.2 not coming. Why not sending out to the candidate IP address 4.2.2? All this should be going out to the network. So the success rate is right now is 0. So there are some default routes. There are some error in the default routes. Let me bring this to this is okay. 10 dot. Why it's pinging this next route is now set to 10. This is no, it's not this 4.2.2. This is 10.0.0.2. Then this is a reply from this 10.0.0.2 from this IP. This should be it should be this 10 dot. Okay, here. This is the last resort is set, and we have to ping it. There is some mistake in this from the tutorial. I copy it out. Okay, now if I'm ping this one, then it's replied successfully. This one. Okay, that's all for this default static route. How to set those things in the default static routes. And let's move on to this routing information protocol RIP2. That basic concepts of this RIP2. Routing information protocol is one of the oldest distance vector routing protocol. Last time we already learned about this link state and distance vector routing protocol. Okay, it is usually used on small network because it is very simple to configure and maintain. So it is very easy to configure and maintenance also. but lacks some advanced features of the routing protocol like OSPF and EIGRP, and hence interior gateway protocol and open source part first routing protocol. Two variants of this, two versions of the protocol exist, version 1 and the version 2 in the RIP. Both uses hop count as a matrix and have the administrative distance of this 122. In the hop count, we can have the administrative distance of the 1 to 20 120 hop counts. In the RIP, version 2 is capable of advertising subnet marks, so it can advertise the subnet marks. Advertise means sharing the informations. Okay. Subnet marks and use multicast to send routing updates. So it uses multicast. Okay, multicast, not broadcast. It's send out to the multiple, but more than one, not all, not all the ports, more than one, to send all the routing updates. While version 1 does not advertise subnet marks and use broadcast for updates. So the difference is that RIP2 advertise subnet marks, advertises subnet marks and uses multicast to send the routing updates. But version 1 does not advertise subnet marks and use broadcast. Instead of multicast, it's broadcast. So version 2 is backward compatible with version 1. So version 2 having this downward compatibility, and also it's some having this advantages in the version 2. It's advertised the subnet marks and also use this multicast instead of broadcast. There are some network conditions and traffic conditions less in the RIP2 routing information protocol version 2. Okay. RIP overview. That's RIP version 2 send an entire routing tables every 30 seconds, which can consume a lot of bandwidth. So it's advertised, it send out the routing table every 30 seconds, which can consume lots of bandwidth. RIP version 2 uses multicast address of 224.0.0.9 to send routing updates. Supports authentication and triggered updates that are sent when a change in the network occurs. So in the version 2, where there are changes in the routers or there are some fault in the routers, then it send out the changes in the network. Okay, send out the updates triggers. So RIP version 2 uses multicast address of this 224. Okay, 224 is the multicast address. If the first octet starting from this 224, this is the multicast address. So based on this multicast address is update the routing informations. Okay, routing tables. This is the working of this RIP, and RIP2 send the entire routing tables every 30 seconds. When can resume a lot of bandwidth, RIP2 use multicast address of this to send routing updates, supports authentications and trigger updates. Router 1 directly connected to the subnetwork of this router 1 R1 connected to the subnetwork of this. Okay, and network engineer has configured RIP of router to advertise the router to this subnet. R1 sends routing updates of the R1 and the R2. Routing update list updates list the subnet marks and metrics for the routes. Each router 1 and router 3 receive this update and adds the routes to their received routers. Both routers list the matrix of 1 because the network is only one hop away. So there is nothing one hop count here. From here also one hop count, so it's one hop away. And administrative distance of hop is 120, so we can it can goes up to this 120 hop, and from here also we can go to this 120 hop count. Then the administrative level of current pictorial is the one hop count away only. So these are the things in this RIP version 2. So to configure those things, number one, enabling RIP by using the router RIP global configurations. Instruct the routers to use RIP version 2 by typing version 2 commands, telling RIP which works to advertise by using one or more networks. So RIP which we work to advertise by using one or two networks. So for telling this version 2, we have to type this version 2 in the command line. The first commands are easy to comprehend, but the last commands requires a little bit more tougher, which the network commands you specified with the interface with the participated in the routing process. These command tags are classful network as parameters and enable RIP on the corresponding interface. Let's see the configuration of this RIP here. Down there we have the network address of this 10.0.1.0, and here 172.16.00. this is 192.168. so this ABC of this private IP address. Okay, and all these are private IP address. So router 1 we have to do it like this, and router 2 do it like this. So those practical disconfigurations we'll do it tomorrow. This how to set up those things in routers. That's all for today. Okay, up to this slide 22. We'll continue slide 21 up to the slide 21. Tomorrow we'll continue in the slide 22. Okay. Okay, that's all for today. Let me call your roll number.